Let's start with question number 22. Now this question belongs to wave optics. The question says in an electron microscope, the resolution that can be achieved is of the order of the wavelength of electrons used, right? To resolve a width of this much 7.5 into 10 to the power minus 12 meter, the minimum electron energy required is close to. So let's start with the solution. As we are aware by de Broglie's phenomena that lambda would be equals to h by p, which can also be written as h by mv, right? Or this can also be written as h upon under root 2 m into kinetic energy of this electron. So from here you can understand that lambda square would be equal to h square by 2m kinetic energy of electron. This kinetic energy can be written as h square upon 2m lambda square. Let's put down the values here. So this k would be equal to 6.626 10 to the power minus 34 square whole divided by 2 into 9.1 into 10 to the power minus 31 into what is the wavelength which is given to us, that is 7.5 into 10 to the power minus 12. So I'll write 7.5 into 10 to the power minus 12 meters whole square. Solving this, you will get K as 25 kilo electron volt, right? Let's see which is the best suitable option here. As far as these four options are concerned, option number 4 is the answer to this question, right? Let's move forward for question number 23. Now this question belongs to a section of heat and thermodynamics. As per the question, a heat source at T equals to 1000 Kelvin is connected to another heat reservoir at temperature of 100 Kelvin by a copper slab which is 1 meter thick. Given that the thermal conductivity of copper is 0.1, the energy flux through it in steady state is. So what do we mean by energy flux? It is basically the ratio of heat flown per unit area, which can be written as K into temperature difference divided by the length, right? Now in here, if you just see that H by A would be equal to 0.1 into 1000 minus 100 divided by the thickness of the copper slab is given to be as 1 meter. So you will find that this answer would be equals to 90 watt per meter square, right? So let's see which is the best suited answer for this question. Among these, option number 4 would be answer to this question, right? Let's move ahead for question number 24. Now this question you can see belongs to units and measurement, that is the part of mechanics. As per the question, the density of material in SI units is 128 kg per meter cube. In certain units in which the unit of length is changed to 25 centimeter and the unit of mass is changed to 50 gram, the numerical value of density of the material is. So let's start with the solution. For any given physical quantity, you can write N2U2 would be equal to N1U1, where N is the numerical value and U is the unit. Let's take U1 as the SI unit and U2 as the new unit, right? So from here, it's a simple formula. N2 would be equal to N1U1 by U2. So what's the value of N1 given to us? It is 128. Let's write it down, 128. Now we are talking about density. So U will be written as M1 by M2. This is 1. L1 by L2 power minus 3. Time is not required here, as in density time does not play any role. So from here you will see N2 would be equal to 128. What is the basic SI unit? 1 kg, 50 gram, power 1, and length is basically 1 meter in SI unit, and here we have taken as 25 centimeter, right? And this is minus 3. Now solving this, what I will get is N2 would be equal to 128. Now for a number, the units cannot survive. So 1 kg, if I want to write, I can write it as 1000 by 50. The units will disappear or they will be cancelled out. And here I have 100 by 25. The power would be minus 3. This is 128. This will be 20 and this would be 4 power minus 3. When you solve this, you will get N2 is equals to 40, right? Let's see which is the best suited option. So among these four, option 3 is the answer to this question, right? Let's move on to question number 25 of our next section.